Hello and welcome to Midwest Tech Training. I'm going to give a quick lesson on component mismatch in RS Logix 500, and I'm also just going to quickly tell you about some of my classes and how I run my classes. First of all, not only do I teach about how to troubleshoot PLC code, I also make sure that in the class you understand how the controls work, and you can actually troubleshoot this motor starter to start if you have an overload. I have that built into the wiring. We can program overloads and motor mismatches. And also, we make sure we understand the electrical diagram. And without being able to understand the electrical diagram and understanding controls, you're not going to be able to troubleshoot this effectively out in the field. So that being said, I'll just give you a quick lesson here on how you would program and how you troubleshoot a component mismatch. Now this right here, you'll see there's an output and an input. And in PLC code, if the PLC is telling something to turn on, which would be an output, it's looking for some kind of feedback to say, hey, I did indeed turn on. And that here is this input. So we have output CR3, which is a control relay, turning on a motor starter. And when that motor starter starts, its normally open contacts are going to close. And we would expect this input here, which happens to be a normally open contact, to change also. And that's actually going to keep this fault from becoming active. And if you watch this logic right here, you're going to see these bits here just flip-flop. Because this is output 1, this is output 1, this is input 4, this is input 4. But this is an XIO bit, this is an XIC bit. So I just stopped it there. You'll see the output's off, so the input should be off. If I start it, the output is on, and the input should be on. And on the training box, what that looks like is this. The PLC sends an output to CR3, say, hey, I want you to energize. And after it energizes, it in turn pulls in this contactor. And when this contactor pulls in, there's a normally open contact, which happens to be right here, that closes, and that sends an input back to the top of the PLC. And on the electrical diagram, what that looks like is this. You have output 1 coming on, turning on CR3, and when CR3 energizes, you'll see here's a CR3 contact right here. That's going to close, that's going to fire this MS. All these MS contacts are then going to close. And you'll see here's an MS contact here going to the PLC input 4. And if I go back to the PLC ladder logic, if I shut this off, I'm going to actually push in this MS contactor right now, which would be a not normal function. And this would simulate that this contactor froze shut and never released. Well, you'll see, now this is true because it's highlighted, that's true because it's highlighted, that stayed true. And this timer started timing. After 2 seconds, it went done and latched this fault. Now I could reset this. Watch the timer this time. Goes enable for 2 seconds and then done. There's my done bit, fires this latch, and because it's a latching bit, even though this went false, this fault stays on. And real quick, I teach how to do a lot of cross-referencing, because cross-referencing is really the key to navigating large programs. So if I wanted to find the unlatch for this, I could cross-reference this. And the OTU is the unlatch. Double click it and it takes me there. It happens to be right below it, but in large programs, that's probably not the case. So anyway, this is just a really quick lesson. Of course, we spend a lot more time on this in the class. We make sure everybody understands it. But I hope you consider Midwest Tech Training for your company's training in the future. Thank you very much.